Hi, so we're going to be figuring out the resultant CO2 through the combustion of pentanol in unlimited oxygen. So knowing that there's unlimited oxygen, right, just in a typical combustion reaction in the air, the limiting reagent is going to be pentanol. So we know that the reaction will stop when pentanol has been exhausted. And in order to figure out such an answer, we're going to have to figure out the amount of moles of pentanol in this. So the molar mass of pentanol is 88.148 grams per mole. And we're going to divide that by the 115 grams that we have here. And we're going to end up with 1.305 moles. So the other values we have are that the pressure is 1.05 atm and the temperature is 75 degrees Celsius, aka 348.15 Kelvin. Okay, and 1.05 atm. So the next thing we're going to do is we're going to use the PV equals nRT, the ideal gas law equation. And actually, I skipped a step. We're going to, first we have to figure out the amount yield of moles of CO2 in this equation. So now we're going to use the proportion of CO2 to pentanol, which is 10 to 2, right? So 10 CO2 over 2 pent. I'm just shorthanding it. And we're going to multiply that by the actual amount of moles, so 1.305. We're going to end up with 6.525 moles of CO2. And now that we have the moles of CO2, we're going to we're going to use PV equals nRT, right? N is the moles. So now we're going to have to do 6.525 times the gas constant, which is 0.082. You put a 1 there, and then multiply that by temperature, which is 348.15. And because we're trying to find, so the equation in whole is P equals nRT, and we're trying to figure out what V is, what the volume is in liters. So we're going to divide nRT by P, and we'll end up with V. So by 1.05. And what we end up with is 177.41 liters. Right? There you are.